Hello everyone, this is Ivy. In the previous courses, we have introduced the feature definition, parameter setting, and the introduction of two-axis milling operations. Now, in this video, we will combine all the previous knowledge and have a case demonstration for two-axis milling. We will follow the general workflow which contains model preparation, add stock, tool creation, toolpath creation, and verification. Okay, now let's switch to ZW3D and begin the case study. Here is the part we are going to machine. We can create a cam plane from right-click menu. The first thing is to do model preparation. We can measure the size of the part. The length is 145. The width is 100 and the height is 20. We can continue to check the minimum fillet radius is 6 and the hole's diameter are 12, 10, and 6.8. So we can use a tool with diameter 10 to do the roughing and finishing for most areas. And we can choose another smaller tool to machine the big and medium holes if we do not have such driller. For the smallest holes, we can choose drill operation to machine. We can also check the Z value of different plane by using coordinate. The top face of middle cylinder is a little lower than the surrounding bosses. Then we add stock. Suppose we have a stock that is 7 mm thicker than the part. Click Add Stock. Then set the top 7 mm more on Z-axis. From here, we can find that the orientation is proper. For other cases, you may need to adjust the orientation. You can do it in CAD module or you can create the frame here. Next, let's create the tools according to our analysis. Suppose we have flat mill tools with diameter 10, 8, 6, 3. We will choose tools with diameter 10 and 6. We can create the directly in Tool Manager. Or we can load it from Tool Library. We can modify the spindle speed and feed value. Finally, let's start to create the toolpath. For the roughing, first we choose top face cut operation to remove the excess material. This operation can also finish the top face of the stock if there's no excess material to be cut. Just select the part and stock as the feature, and D10 as the tool. Set the operation parameters. Due to we use the part and stock as the feature, so there's no need to set the limiting area. As to the tolerance step, we just need to set the step down type, uniform depth, and value. And the left setting, we can just leave it by default. We can double-click the operation icon to hide the toolpath. Let's check the left outside area. We can machine it by spiral operation for roughing. This time we need to create a profile feature to specify the machining area. It is a little time wasting to pick all edges for the profile here. We can just insert a sketch quickly. And then add the feature by selecting this sketch as the profile. Here we can see that this is an open profile, so we can set the open part, the tool location as path boundary. After that, we choose the tool. Then let's check how to set the operation parameters. For limiting, we can set the top point. For tolerance and steps, we set the step down type and the value, and also the side stick and bottom stick. Just leave the bottom stick for finishing. Then for path setting, we can set the side finish type as single cut cleanup, number 2, and distance. We can calculate to check the two paths. As to the path pattern, here we can engage it from outside of the path. So we can select the step inward, calculate it again. We can find the two engaged from outside now, which is much safer. We can also optimize the lead-in and lead-out. Set it smaller to improve the efficiency. Calculate. You can find that the engage and reject toolpath is much shorter, and it is still safe here. We can put the tool to check. On the right side, we can just use mirror to get the toolpath. Then we can continue to create the toolpath for these slots. This is an open profile, so we can use profile or contour operation. Here it is a narrow slot, so we will choose profile to show you. Click profile operation, create profile feature. Keep the tool location as tangent to boundary. OK, select the tool. Go to Operation Parameter dialog. Set limiting. Bottom seek. Step down value. Site finish. And the link and lead. Calculate. Done. If you find the direction is incorrect, then go to change the machining side. In the middle pocket, we can use the spiral operation. Here you can see this operation is similar with the spiral cut one. The difference is that the two locations for the whole profile is tangent to boundary, because it is an inner pocket. The same as the spiral cut 3. Now let's check about this final pocket place. We can just duplicate the existing spiral operation. Then remove the feature and add a new one. Then we go to the parameters to redefine the limiting. Tolerance and steps OK. Path setting OK. Link and lead. The plunge setting is OK. Let's calculate. We can see that the plunge toolpath is not helical. The reason is that there's not enough place to go with the helical. We can just check. Here the helical diameter is 9. And we can draw a circle which is centered in the start point. The circle is the supposed helical toolpath. If we machine it by this toolpath, there will be a clash with the middle bus. So ZW3D deals with it by the secondary strategy which is ramp toolpath intelligently when the helical cannot be met. We can also optimize it by adjusting the parameters, like set the path pattern as step inward and specify the starting point. Here we need to specify the point and click middle button to confirm and then calculate. The plunge path is helical now. There's also another point we need to pay attention to, such as this place. You can find the corner toolpath is too sharp, which is very bad for tool. We can set the concave corner type as round. Now we have finished all the roughing toolpaths. That's checked by Solid Verify. We can adjust the update interval and play to check final result. We can click Options, go Analysis tab, and click Visual to check the left material. It is obvious that except the holes, there are still some islands. And in the middle box, we need to do rest roughing. Let's go to check the corresponding toolpath. Here we can find there's a gap, so we can just go to adjust the step over to a smaller value to check. Now it's okay. To remove the left material around the middle cylinder, we can just add a profile cut operation. And set the parameters. After roughing, we need to create the finish toolpath. First, we can finish the outside area. Duplicate the spiral cut operation. Then we need to modify the operation parameters. Due to the speed and feed of finish will be different from rough operation, we can adjust here. Next, we can set the limiting area. Bottom thick to 0. Step down type as space only. And side finish type as none. Calculate. Done. On another side, we can mirror the toolpath. Next, let's check how to create the finish toolpath for this area. We can use the contour operation. Create the feature. Select curves. And set the tool location. Then we choose the tool. And calculate. Of course, the result is not bad, but we still can optimize it. As we can see, we always go back to the initial level when we go to next toolpath. So we can go to operation parameters to adjust this. Go to link and lead. Set inside the region type as blank plane. Calculate. Quite good now. We can also set the lead in and lead out. Another way, also better one, is that we can set the cut direction to zigzag. Let's check the result. It looks much better. Then we can pattern the two paths for the others. We can add a spiral cut operation to finish the top face of the middle cylinder. Next, let's check the final finish operation. Same way, we duplicate the spiral roughing operation. Set the limiting area. Set the side thick and bottom thick as 0. Step down type as space only. In path setting, to finish the side we leave, we set side finish type, number, and distance. Then calculate. Now we have finished most areas. There are many operations. To make it look tidy, we can create operation folder to manage them. Roughing and finishing. And we drag the corresponding operations into its folder. Okay, at last we need to create the two paths for all the holes. Suppose we have no big driller, so we need to machine the big and medium holes by mill tool. First, we can create a folder named Hole Machining. Then insert the operation. Here we choose RAM to mill the holes. Create the profile as feature. Choose the tool. Then calculate. We can find the machining side is incorrect. Go to Parameters, change the machining side. Set the limiting area. Here we can specify the bottom point. And then input the value deeper than that to make sure the through hole is fully machined. Then set pitch, side finish number and distance. Calculate down. Same way to create the two paths for the medium holes. As to the smallest one, due to we have the driller, we can just insert drill operation and add the feature. Create the hole feature. select the driller. We can load it from tool library. Then we calculate. We can find that the link toolpath goes through the pad. So we can go to the parameters, adjust the return type, or modify the return distance to a little higher, like 10. Recalculate. Better now, GW3D also provides an auto-void solution. As long as we include the pad as the feature too, it will avoid the collision with the pad automatically. Till now, all two paths are done. So we can use Solid Verify to check the result again. Okay, the result is quite good. That's all for this case study. Thanks for watching.